Construct the truth table for this logical statement. This is exactly the same one that we worked in the previous problem, so if you didn't see the previous example, you might want to go back and look at that, because I'm going to take advantage of the fact that the previous example asked us to find the truth value for that same statement with particular values of P, Q, and R. So I'm going to go ahead and take advantage of that. The previous problem asked us to do the truth value for that expression if P were true, Q were false, and R were true, and we worked it out and found out that it was true. So I'll go ahead and put that in, so I want to do it again. It's just a little time-saving device. Beyond that, however, we've got to evaluate this for 7 more combinations of possible truth values. Remember, with 3 simple statements, P, Q, and R, there's 2 to the third, 8 rows in the truth table. That's why even saving me having to do 1 was a good idea. So I've already got this one from an earlier example. But now I want to go 1 row at a time and replace the P, Q, and R's with the trues or falses based on what line of the truth table I'm on. I don't want to take too much time with this because it's just busy work, but I will say all I'm doing here, for example, in row 1, is I'm putting trues in everywhere. You notice the P became true, the Q became true, the R became true. All of them are true. In the second row, the P's and Q's were true, true, true for Q, true for P, but the R is false. And then as you move down, I won't do every one of them, but any row you take, in this one I'm taking a false for P, so you can see where P is, I put in a false and a false, and where Q was, I put in a true, so that would be a true here, and then where R was, I put in a false, it would be a false there. So you can go down and see. I'm just saving a little time by just popping that information in. Now usually I've been working these problems, so I'm using the same column, and I'm taking advantage of my technology to just simplify as I go, staying in the same column. But this time, because you don't have that technology while you're solving a problem, I thought I would solve it a little more like the way you probably have to do it. So I'm going to take that result and give myself a little more room and just work it out on the side without covering up the old material. So this is more like the way you would have to do it without the technology that I'm using. And the first thing I would do is going into every position and replacing the negations with their opposites. So, for example, in this first line, I would have true or false, or true and false. Notice I replaced all the not trues in the first line with falses. Same idea in the second row. I'll take the not true and make it a false, and I'll take the not false and make it true. Now I'll show you another thing. Of course, I've already got this true, so this is the final result of this is true. I'll just go ahead and put it over there. I won't worry with that row. But one thing I will notice is when I'm doing a lot of the same sort of thing, I can set up the problem all the way down for what's going to be the same, and then I can go in and fill in the gaps, and you might find it useful that way as well. I'm doing this purposely so you can sort of see some of the tricks that I use to try to cut down on mistakes. So everything's got an or here, and then I have a true and I have a false and I have a false and false and false and. Okay. So now I can look and I see now that this not false becomes a true, and this not false becomes a true, and this not true becomes a false, this not true becomes a false, This not true becomes a false. This not false becomes a true. This not false becomes a true. This not true becomes a false. This not false becomes a true. And this not false becomes a true. So I'm sort of working my way down. Now I continue, and I'll put the equivalent sign between them as I work my way down. Equivalent to, equivalent to, equivalent to, equivalent to. So then I want to look and see inside of these. This is an OR. True ORed with false is true. And true ORed with false is true. And true ORed with true is true. And false ORed with false is false. And false ORed with false is false. And false ORed with true is true. And false ORed with true is true. And then the next ones are all ORs, so it'd be OR, 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 OR. And then I want to go here, and I got true ANDed with false is false. True ANDed with true is true. True ANDed with true is true. False ANDed with false is false. False ANDed with true is false. False ANDed with false is false. And false ANDed with true is false. And finally, last step, put my equivalences in. And this is sort of the way I suspect you would do it. Now I'm ORing, and a true ORed with false is true. And a true ORed with true is true. And of course we already knew the third line was true from the earlier problem. True ORed with true is true. False ORed with false is false. False ORed with false is false. True ORed with false is true. And true ORed with false is true. So if you look at this, the truth values are in the last position of the last column, and I want to clean that up a little bit, but I wanted to do it this way as opposed to the way I've been doing it, to show you how you would do it without the technology that I'm using. Still pretty simple. But in any case, that cuts out the clutter. All I was really interested in was the end result, so I just take out all the scratch work from the beginning, and that is the truth table that we were instructed to create right there.